Hello again, and welcome to machine learning tips. So today we are going to be looking at two very important concepts in machine learning, which is called like data normalization and what data centering. They are a little bit related, but still has some discrepancy. With normalization, normalization is a technique in machine learning that like scales a range of future values. Future values here in the data frame we mean like the columns, so that no future dominates the other simply because of maybe their weight. Let's say we have a situation where we have a data set where we have like the height of someone and the weight of someone. We can see that the height there might have a lower values as compared to the weight. So in that case, machine learning models like the k-means algorithm that are mostly based on this computing the distances between those futures or rely on magnitude might not really be the best, might not really work well in those situations because of the discrepancy in between the weights for those futures that I did mention. So in that case, we need to scale those values to a particular range. So that most of those machine learning models that I did mention, like K-means, the KNN, and so on, that can work well. Another second technique is what we call data centering. Here, we are trying to center the data by shifting the data so that it's close to its mean. And why is that very important? So that, the future distribution is centered around what? Around zero. This concept is important for dimensionality reduction methods like the principal component analysis. I did mention this earlier when I was talking about unsupervised learning methods and other linear models, just because the covariance matrix assumes that the data is like zero centered. So the first one example of the normalization technique here is called what we call range normalization. This range normalization in machine learning, some people call it min max normalization. So it's either you call it the range or what the min max normalization is going to scale those values to a range of what 0 and 1. And the formula is like we get every value in the column of this data set. We pick the minimum value for that column. We subtract it from every value, and then we divide by what? The maximum and minimum value in that column. So let's say for demonstration, we have created a data set here. Let's run this and we see the data set. So this data set, we can see that the second column here has higher values like 50, and the first column here has very low values like 0.2. We even have some like minus 0.5. So in that case, machine learning models that that depends on computing the distance between those futures might not really work well in such cases. So it's preferable we normalize that data so that it can be within a particular range. So if we normalize this by using that formula, if I run this here, we can see that this data now is centered around what? 0 and what? And 1. So another concept which is under the data centering is what we call mean centering. We subtract the mean of each attribute from its value. So meaning that we take the value for each of those columns, we subtract it from the mean, and then we run this. When we run this, we should be having something like this, which works well for concepts like the principal component analysis and linear models. So for the z-score normalization, is another data normalization technique, which we call it the standard normal distribution. We are going to see this when we come to statistical concepts like the normal distribution and so on. So this simply transforms any attribute or feature in a data set based on what their standard deviation. So that the first concept is that it takes like every value in that data set, subtract it from the mean, and then we divide by what the standard deviation. So we call it a z-score, as I did mention. We are going to see this, and then it also like centers those the values in that data frame within a particular range between 0 and 1. So when one thing you have to note here is that when we do like the mean center for every data set, and then the mean for that center data will always be 0. So if I run this, we can see that the mean for this first column, Its value is minus 7.93 to the minus 17 is approximately 0. So that was it for today, guys. Tomorrow we are going to be looking at different statistical distribution. Thank you so much. Bye for now.